The weights of edges in a graph are shown in the table above. There we go. Apply the sorted edges, also called cheapest link, algorithm to the graph. Give your answer as a list of vertices starting and ending at vertex A. So for example, there. Okay, so what is this table saying? This table is saying these are a bunch of cities, I assume. So city A, from city A to city B, it's 34 miles. Right? That's why A and B connect there at 34 miles. How far from city A to city C? Only 10 miles. Cities A and C are close together. From A to D is 39 miles. From A to E is 18 miles. From A to city F is 26 miles. Now we see all these same numbers repeated right here because this is A to B, just done the other way. And then A to C. And then A to D, just done vertically, A to E, etc. That's why all these numbers are repeated right here. See, those are identical sets of numbers. So you don't have to use both sets. They're repeats. So from D to B, for example, is 16 miles. You could do it there, or you go B to D right here, same 16 miles. That's how far from between cities B and D. So that's what that table means. Now let's use that table and let's use the, what did they say, sorted edges or cheapest link algorithm to find a path that is a circuit that is as low as possible with the sorted edges routine. So remember how the sorted edges routine works. Let me remind you here. Sorted edges. Basically, it's pretty simple in a sense. You always pick the lowest edge anywhere on the map. Not just among, not only, how about I say not only among those connected to your current spot. So the emphasis here is anywhere. Pick the lowest edge anywhere. That's basically the plan. So you just look over the entire map and just take the lowest edge anywhere. But there's two no-nos. Number one, do not pick an edge that will close a circuit, a loop, too early. Meaning leaving out one or more cities. So make sure you don't pick an edge that will close a circuit too early, leaving out one or more of the cities, right? Our goal in this is to form a circuit that will visit all the cities. This is called the traveling salesman problem. In other words, the whole purpose of this question is if you were a person, well, really it's like FedEx or UPS or the Amazon, who needs to deliver to several different cities. So whoever makes that delivery has to get on a jet plane or get on a truck and travel from city to city to city, and he's got to visit all the cities. He's got packages to go to all the cities, A, B, C, D, E, and F, and then he's got to come back home when he's done. So he's got to make a circuit visiting all the cities. You can't close your circuit, your loop, too early and leave out some of the cities where you don't deliver the packages. So the practical nature of this question, it's asking us what's, and the people that really care about this is, the UPS and FedEx and Amazon and stuff, because they want efficient ways. They want the quickest way possible to visit a bunch of cities in a circuit and come back home. But they don't want to waste time making trips between cities that are inefficient. They want to know what's the easiest way to connect between all the cities and come back home where we use the least time and gasoline and money, basically. So anyway, so we're gonna use the method here. We have the nearest neighbor method, we had the repetitive nearest neighbor method, and now we have the sorted edges method. And so you always pick the lowest edge anywhere, not just among those connected to your current spot, anywhere. But there's two no-nos. I got to get you the second one. The two no-nos. The first one is don't pick an edge that will close a loop too early, and number two, do not pick an edge that makes 3 hits on one city. You don't want 3 hits on a city. Let me write that better. 3 hits. That's the other no-no. Why not? Well, because think about a loop. Let me just draw up here real quick a loop. A, B, C, D, E, F. When all is said and done, I want some kind of path that goes between all the cities, right? I don't know that that's the exact path, but I want some kind of circuit. Meaning, look at city F, for example. He has 2 hits on him. You come into city F and out of city F, don't you? Or in city C, 2 hits, right? You don't want like a third road hitting. That's silly. That's not how a loop works. You only want 2 hits on every city. That's what it means to make a loop, a circuit. All right, so that's the plan. All right, so here we go. Let's start doing it. What I suggest is to draw a map as you go. That'll make it easier. Here we go. So first off, what's the lowest edge anywhere? What's the smallest number you see? I'm looking at 6. Yeah, I think that's it. There's also one here. That's the same one. Remember, they're all repeated. That's a connection between city F and B. Those are the closest 2 cities. So B and F. So I'm just going to draw a connection right there between B and F. That means B and F. We just picked an edge, a road between B and F. Now we keep going. Now you might say, well, yeah, but they want vertex A. We'll make that work in the end. We just keep going for now. So we got that checked off. So now let's pick the next one. What's the next lowest number? I'm looking at 10, right? Which is also, oh, no, 8. Looks like I'm missing it. Better be careful. 8, these 2 8s, which is between what? Between city E and D. Same thing here. D and E. So between D and E, so I'm just going to put that down here. D and E. That's another road. So I'm picking my roads. I'm looking at the map saying, hey, I want to take the road between B and F. It's only 6. And I want to take the road between D and 8. It's only D and E. It's only 8. Because those are the lowest roads on the map. Sounds like a good plan. We just have to eventually connect everything up, and we will. So let's keep going. Next, what comes after the 8? Now's the 10, right? The 10, which is here and also there. Yeah, I'm not missing anything. Okay, so that's between C and A. Same thing here, A and C. So that's the road between A and C. So let me put that over here. I don't know how to do it. Let me just go A and C. Well, here, let me do it vertically. It doesn't matter. Just, you might have to redraw things. I'll go A to C like this, and that's a 10 road. So again, I'm picking roads, A and C. That's the next lowest road on the map. All right. Keep going. What comes next? Is it that 18? I'm thinking 18, right? That's the next. Oh, no, 16. You got to be careful. 16 is the next number. Yeah. And there's also 16 there. Okay, so that 16 connects D and B. Ah. D and B. 16. Now, is that okay? Remember, we had a couple of no-nos. Does that break one of my no-nos? Well, let's take a look. Don't pick an edge that will close a circuit, a loop, too early. Did we just close a loop? Is there a complete loop there? No, no. If we did that, that would be a loop. Then there'd be a little circle there, but that's we don't have that. We don't have that road. There's just there's not a closed loop yet. That's okay. And number 2, do not pick an edge that makes 3 hits on a city. Are there 3 hits? See, B, no, it's good. B has 2 hitting it. D has 2 roads hitting it. The other guys all have just 1 road hitting them. No, that's good. That's totally a good one. We'll take it. So there's the 16. What comes next is the 18. 18 here and 18 there. That 18 connects E and A. E and A. So I'll do that. E and A with an 18. Now, is that an okay, or does that violate one of my no-nos? Well, let's see. Don't pick an edge that will close a loop. Did that close a circuit? No. No. Again, if I'd done this one, that would close a loop, right? Or if I did this one next, that would close a loop. Can't do that. So, but EA is okay. That doesn't close a loop. How about number 2? Don't pick an edge that makes 3 hits on a city, right? We only are going to have, when we're all done, we're only going to have 2 hits on every city. We go into a city and out of a city. That's what it means to make a circuit, right? Does that give 3 hits? No, there's only 2 hitting E, and only 2 hitting A, and only 2 hitting B. That's good. There's not 3 hitting any city. So that's acceptable. Great. Doing great. Let's go to the next one. What comes next? After 18. Looks like 20, right? 20? I think 20. 20 here and there, right? Yeah, that's the next number. 20 is a connection between E and C. Same thing here. C and E. 20. So 20, E and C. So E and C, there it is, 20. Can't do that, can we? That's a no-no, right? Because that makes a loop. See that little triangle there? That's a loop. These 3 cities are looping, 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 and we're not it's a circuit without hitting all the cities. If we just circulate between A, E, and C, we're not going to get to all the other cities. So we can't do that. That 20 is a no-no. Let me take it away. So that's a no-no. Let's go up to the next number. What comes next after the 20? Is it the 26? I think. Yeah. 26. Here and here. And that's a connection between F and A. A and F. 26. A and F, 26. Let's do it. A and F, 26. It's another no-no, isn't it? This time, it's not a loop. It's not a violation of the first no-no, but it's the second no-no. That's 3 hits on a city. Do you see how city A right now is being hit 3 times if we put that edge in? That can't be. That's not how a circuit works. It's only 2 hits on every city. You go into the city and out of the city. That's what a circuit means. So 26 is a no-no. Let's take it away. Can't do it. What's the next number? 27. Right there. 27 right here. That's a connection between D and C. D and C. That'd be right there to there. D to C, that's a 27. Is that okay? Nope, that one's not okay either, because you see the problem? Look at D. That's 3 hits on city D. That's 3 roads coming into city D. That's the second no-no. You're only going to have 2 hits on every city, so that can't be the case. At this point, really, we should be using common sense. Here at the very end, first off, we have all the cities out there, right? Here's A, B, C, D, E, and F. They're all out there. They're all connected, except they're not a loop yet. But there's only 2 open ends. What are the 2 cities that are open? C and F. It's got to be C and F. That's the only way that you can possibly close this loop. Do you see? It doesn't matter what method I'm doing right now. Nearest neighbor, repetitive nearest neighbor, or sorted edges, called cheapest link, it doesn't matter. You've got to close a circuit in the end. And we've chosen all the other roads. So we have no choice left. The only road that's going to work to finish this and make it a loop is the FC road. So we've got to go with that because those are the only open ends to form a loop. So let's grab the FC road. What is the FC road? Well, it's right here. No, that's not it. Try again. FC road, it's right here. And it's also right there. So there's the connection between F and C and F, 29. So that's 29, the CF road. So now we have a circuit. We have a circuit. It visits all the cities. Now, we have to rewrite it starting with vertex A, right? Starting and ending with vertex A. So let's do it. So start at A. In fact, why don't I change my color so we can see this better? Let's start at A, right here. And it doesn't matter which way I'm going. I'll go this way to C. And then from C, we go up here to F. And then over here to B. Then down here to D. And over here to E. And then over here back to A. There it is. Or, remember, you can always run these backwards. Right? There's two ways to give all the answers, and make sure you pay attention to that on the multiple choice exam because they could have it listed either way. So let's go backwards. Go this way now. Start at A, go E, D, B, F, C, back to A. That's the same loop. Those are the same loop. Let's see it. Let me use another color and let me show it to you up here. Let me show you this loop up on the map. Start at A, go to what? E. Next comes E. Where's that? Yeah, right here to E. Followed by D. See, we're following the map exactly. To B, to F, to C, back to A. See, that's the same loop. It's just doing the loop backwards or the other way. So these two answers are really the same exact loop. They're just doing the loop one way or the other, starting and ending at vertex A. So there we go. That's the sorted edges method. Notice how I made a map and showed the connections as we went, and I made sure I did not violate the two no-nos. I just kept picking, I always pick the lowest edge anywhere. So it's not just the lowest edge next to where you're at. That's what confuses students, because that's what we did with nearest neighbor and repetitive nearest neighbor, is we always just took the lowest edge next to us. But sorted edges, we're picking the lowest edge anywhere. So this is the key phrase that you've got to get straight. Anywhere. Except for the two no-nos. You can't make a loop, a circuit too early, leaving out one or more cities, and you can't pick an edge that makes 3 hits on any one city. As long as you don't do those no-nos, just keep picking the lowest edges and making your map until you've connected up a circuit. There we go.